Hello, linear algebra student. This is for chapter 1.6, applications of linear system, basically work problems. A lot of economics and engineering problem can be solved by linear systems. So we're just going to go over 3 types of equations. These are primarily from the book with small adjustment, so you can see both. You can also read the book's example as well as these notes. The first is application in economics. So what happened is we just simplify it down to saying the economy had 3 sectors: coal, electric, and steel, and the output of each is distributed below. Coal sells 65% to electric, 35% to steel. Electric sell 40, the rest it retained for itself because it needs coal for its no, okay, it sell everything out. Okay, and an electric sell 40% to coal and 50% to steel and retain the rest. Steel sell 60% to coal and 20% to electric and retain the rest. So this is a closed economy. They sell to each other to manufacture output. And so we would look at how the income matches the expenditure. The output would be coal sell these percentage. So whatever that is described above would be a column. Okay, steel sell 60% to coal and 20% to electric. So there's 20% left over for steel itself. And then if you look at horizontally, 40% of the electric is being purchased by coal, and 60% is being purchased by steel. 60% of steel is being purchased by coal also. So in order for coal to be able to purchase this, the purchase price would be PC. So we can actually write the equation like this. PC would be the total output price for each individual sector. And so the column tells us where the output goes. The row tells where the needs are. And then in order for coal to manufacture something, they have to purchase electricity and steel. And that is actually 40% of electricity and 60% of steel. So we record it this way. PC is equal to 0.4 PE plus 0.6 PS. Likewise, this is something that electrics need to purchase. PE would equal to, they will have to purchase coal as well as whatever that they retain. So it's 0.1 and 0.2. The last row would be purchased by PS. They use all the output to purchase 0.35 of PC, 0.5 of PE, and 0.2 of PS. So the most important things to know is vertically that it has to go to 100% or 1. Horizontally, this describe different output price. So you set up an equation like this, and if you subtract everything on one side, then you will have a homogeneous systems of PC minus 0.4 PE minus 0.6 PS equal to 0. Likewise, PE would combine with the 0.1 PE, become a 0.9 PE here, but you want to arrange PC in the front, so it would be negative 0.65 PC plus 0.9 PE minus 0.2 PS. Likewise, you move everything over PS, combine with PS here, so you would have equation like this. So these systems of equation can be solved by, of course, augmented matrix. So we write it as an augmented matrix of 1, negative 0.4, negative 0.6, 0, negative 0.65, 0.9, negative 0.2, 0, negative 0.35, negative 0.5, 0.80. So you can see that the diagonal is positive, and then all the rest are negative, and it is a homogeneous system because the total expenditure is equal to the total output. It's a closed econ system. And then you do a row reduce factor, and it become I put it here already. So if I do a row reduce A, it become like this. 1, 0, negative 31 over 32. So instead of doing fraction, we can actually just do, we can do fraction or we can do decimal. So I would just want to do decimal. So it'll be 1, 0, negative 0.97, 1, 0, negative 0.97. That's what the book does. 0. So there is solution. 0, 1, negative 0.92. 0, 1, negative 0.92. Also 0, and then 0, 0, 0, because you have two prefix column and one free variable. So you would say PC is equal to 0.97 of PS. PE, electrics, is 0.92 of PS also, but PS is free. So we can write it as a, if we know PS, like for example, if PS is 1 million or 100 million, then PC would become 0.57 of T. PE is 0.92 T, and then PS is T. And you can plug in T to see the output price. The second one is for chemical balancing chemical equations. So you might have learned this in chemistry, and it's quite difficult when you have a lot of molecules added together to produce more molecules. But the based on what conservation of matters, the number of atoms on two sides must balance. So we would construct a matrix, construct a vectors. The first number is the number of carbon. The second number is the number of H hydrogen atom, and the last is the oxygen atom in each of this compound. So we will record C38 as 380, O2 as 002 because there's only two oxygen. CO2 is 102, and H2O would be 0 2 1, right? So we record this, and then because we are doing a balance equation, so x1 of this particular compound molecule plus x2 of the second one it would equal to x3 of this one plus x4 of this. So this is how you set up the unknown, and then using the vector, you can do that. And this is the same as solving, adding, so we can move it over and do a minus x3, but instead of doing minus x3, we say plus x3 and 4. But change the vector to negative and negative on this side, right? So when you do the subtract over, you change the vector. So this become an augmented matrix of 3, 8, 0, 0, 0, 2. You're solving a -1, 0, -2. So it's a linear combination of four vectors to be 0. 0, -2, -1, 0, 0, 0. Row reduce row echelon form. So put it in. I have it here. 0, 0, 0, 3, 8, 0, 0, 2, -1, so -2, -1. So reduce row vectors of B. It become, let's do a exact value. So x1 is equal to is equal to 1/4 of x4, right? This is x1, x2, x3, x4. x2 is 5/4 of x4 when you move it over. x3 is 3/4 x4. And x4 is free. For the least integer, if we let x4 equal to 4, then we would have x1 equal to 1, x2 equal to 5, and x3 equal to 3. So we can balance it as, write it out. 4 C3H8 plus x2 is no, x1 is 1, so this is 1 C3 plus 5 O2 would produce x3. x3 is 5. What? X3 is 3. 3 CO2, run out of space, plus 4x4. Double check. So if I count oxygen, I would have 10 oxygen here and 6 and 4x2O, 4x2O and 4 oxygen too. So that's 10. So that's how we balance it. And then in the next video, I'll talk about network flow. Okay, using a system equation to solve network flow.